Dear students, welcome to my lecture which is on photochemistry. So, this particular topic which you will study at 6th semester in Physical Chemistry 1. So in this particular topic we are going to learn what is photochemistry and what are the different photochemical laws and then photochemical process, different photochemical process involved in the photochemistry. So we first start with the introduction. What is meant by photochemistry? So photochemistry is the study of chemical reactions which are brought about by the light energy, that is absorption of light energy. So when light is given to the material, they started to react, right? Those kind of reactions are called photochemical reactions. Then for having better understanding about photochemical reactions, first of all we should know the that is light radiation. We should have some basics about light radiations. So what you are seeing in this slide, so this is the entire range of electromagnetic radiation which starts from the low frequency light radio wave and then microwave, and after microwave the next higher frequency light is infrared, and then we can have that visible region which we can able to sense that particular light. After visible light, ultraviolet will come, and then next higher frequency light energy is X-ray and then gamma ray. So this is the complete range, or we can say spectrum of electromagnetic radiation. Spectrum of electromagnetic radiation. In this, the visible light itself having a broad range, right? So which starts from red to violet. So that we call commonly VIBGR. And this particular region itself will cover from 400 nanometer to 800 nanometer. And mostly this visible region and ultraviolet region which are mostly responsible for the chemical reactions, because these regions they can make electron transfer or electron transition. They can promote electron from lower energy level to higher energy level, or we can say these light energy they can activate the molecules. Okay, we collect some more information regarding electromagnetic radiation, that is different type of properties or the parameters which we study about electromagnetic radiation. So wavelength, frequency, and then energy, and then wave number. So these kind of 4 different parameters can be used to study the nature of light. So the frequency and wavelength both are related mathematically by using the equation C is equal to nu into lambda. And the energy of light which is related with frequency by using the relation E is equal to h nu. E also can be related with wavelength. E also, that is energy of light, also can be related with wavelength. E is equal to hc by lambda. And in this, upon seeing the relation between energy versus frequency and wavelength, we can get some idea, that is how the energy is related with frequency as well as wavelength. So energy is directly related with frequency, whereas in case of wavelength it is inversely related. Now with this basic information, let's move to next topic. So before studying detailed about photochemical reactions, first of all we would see the differences between photochemical and thermochemical reactions. So photochemical reactions which are nothing but the reactions initiated or reactions which are taking place in the presence of light, particularly after absorption of light energy, that is photochemical reaction. Thermochemical reactions, so those reactions occurs either in the presence or in the absence of light energy. But in thermochemical reaction, heat energy may be involved. Heat energy may be involved. Then the photochemical reaction which depend on the rate of the reaction, which depend on the intensity of light energy used for doing the reaction. Right? Intensity of light energy. The rate of the reaction depends on intensity in case of photochemical reaction. Whereas in thermochemical reaction, the rate of the reaction is independent. The rate of the reaction is independent, which is not affected by intensity of light radiation. Then photochemical reaction, which is independent of temperature. That is the rate of the reaction not affected by heat energy in case of photochemical. Whereas in thermochemical, the reaction depends on the temperature. If you change the temperature, the rate of the reaction may be increased or decreased. Then final difference. This is a very important difference between photochemical and thermochemical. Photochemical reactions will have delta G value either positive or negative. Right? Photochemical reactions can have either positive delta G or negative delta G. What is this delta G? It is free energy change. It is free energy change. This delta G will decide whether the reaction should be spontaneous or non-spontaneous. According to thermodynamics, delta G should be always negative. It should be always negative in order to be a reaction spontaneous. But look at this photochemical reaction. Even for positive delta G also the reaction can be spontaneous. That is the speciality of photochemical reaction. Whereas in thermochemical reaction, this would strictly follow the spontaneity, criteria of spontaneity. That means it occurs only when the delta G is negative. Right. Now let's study about different laws involved in photochemical reactions or in photochemistry. So this is the first photochemical law, or we can say the Groth-Schaper law, which was developed by two different scientists. And this is a very basic and we can say principle of photochemical reactions. This particular law is said principle of photochemical law or the fundamental photochemical law. What is this law saying about? Only light which is absorbed, can bring the chemical reaction. What is this only light which is absorbed? Then what will happen when light falls on the material? Look at this picture. When light falls on the material, so many processes possible. Light can be transmitted, light can be reflected, light can be scattered, it can be refracted, right? Apart from that, absorption. Then out of these so many processes, if light is absorbed by the material, then we can expect chemical reaction. But then as per this law, if you see the rate of reaction versus number of photons absorbed, we should get 1:1 ratio. But in many photochemical reactions, the ratio of number of photons absorbed and the number of chemical molecules reacted would not be the same. Then we need one more law. So this is our second photochemical law, which is called Stark-Einstein law. Stark and Einstein law. Then this law assumes the photochemical reactions occurs in two steps. Photochemical reaction occurs in two steps. The first step, a primary process. First step is a primary process, and the second step, that is a secondary process. In the primary process, the reactor absorbs light energy and goes to the higher energy state, that is excited state. From that excited state, it moves to the second step. Where the excited molecule can take part in the chemical reaction. And can be converted into product. So that is the secondary step. And in that, the primary process is a reversible one, which means the after absorption of light energy, the reactant, that is molecule A, can go back to the ground state, that is original form, without involving in chemical reaction. That is also possible. That's why we are getting different ratio between the amount of light absorbed and amount of reaction taking place. And here we can make the relation between energy of photon as well as the frequency. So, and 1 mole of photon, the energy of 1 mole of photon, which is denoted by the term Einstein. And mostly in chemistry, the people will use Einstein scale for measuring energy of the light. Now let's see what is meant by quantum yield. What is meant by quantum yield? Quantum yield is nothing but it is the ratio between number of molecules reacted, and the number of photons of light absorbed in the same time period. And this quantum efficiency may be equal to 1 or greater than 1 or less than 1. If it is equal to 1, equal number of photons and molecules reacted involved. If quantum efficiency is less than 1, more amount of photons absorbed but less reactions are taking place, less number of molecules reacted. If quantum efficiency is more than 1 means we can see sometimes it can be 10 power 3 or 10 power 4, that is 1000 or 10,000. It goes like that. So in such cases, every photon can cause more number of chemical reactions. Then single photon can convert many reactant into product. In such cases, the quantum efficiency would be more than 1. The number of molecules calculation, this is a fundamental mole concept. By using that, we can calculate number of molecules. The number of molecules which is equal to weight of the sample divided by molar mass and Avogadro number. So by using this basic mole concept formula, we can calculate number of molecules reacted. Okay. Next, we are going to study now photophysical process. Photophysical process, which is explained by the very famous diagram called Jablonski diagram. By using this diagram, easily we can explain photophysical process. Then first of all, we see what is meant by photophysical process. Photophysical process, which is nothing but if a substance absorbs light energy, it has to involve in chemical reaction according to photochemistry. Sometime the molecule won't go for chemical reaction. Then if it is not involved in chemical reaction, what happens to that excess energy absorbed by the molecule? That would be returned back either in the form of heat or in the form of light. That was analyzed in this, or that was clearly explained in this Jablonski diagram. So the excess energy, right? The excess energy would be returned back either in the form of light or in the form of heat. Then we can say, so those two processes, if that excess energy is emitted in the form of heat, which we call it as non-radiative transition, non-radiative process. Then if that excess energy is returned or released in the form of light, that we want to say it is radiative transition. Then in this Jablonski diagram, both radiative and non-radiative transitions were properly explained. And what you are seeing here, each line is nothing but it is energy level of molecules, and those levels were labeled as S0, S1, S2, S3, and on the right hand side you could see T1. After T1 we can have T2, T3, like that. Multiple energy levels will be present in the molecule. What is meant by S0? S0 is ground state of the molecule, ground state energy level of the molecule, and at room temperature, under normal condition, all the molecules will be staying in this S0 state, S0 energy level. Then S1, that is first excited singlet state. What is meant by singlet state? There the molecule will be having only paired electron, or we can say the spin of the molecule would be 0. Whenever the spin of the molecule is 0, we have to say it is singlet. Then if the spin is 2, it is a quartet. If the spin is 1, that's called triplet. If the spin is 1, that is triplet, and what that we are seeing in the right hand side, T1. T1 is nothing but first excited triplet state. Next to T1 you could see T2. T2. Like that, various energy levels would be present in the molecule. When light is given to the molecule, it would absorb the light, and based on the amount of energy, it may jump to any one of the excited singlet states. And in the next page, you could see a clear picture about various transitions involved. And what you are seeing are two different type of arrow marks. You could see one is normal arrow mark, another one is zigzag arrow marks. The zigzag arrow marks indicate that heat is involved, and the normal arrow mark which says energies in the form of light is involved. Then if you give some amount of light energy to the molecule will move from S0 state to any one of the excited singlet states, either S1 or S2. From S1 or S2, slowly it will come back to the ground state. Say for example, we take the molecule moving from S0 to S2 state. S0 to S2 state upon absorbing light energy. Then S2 state, which is unstable because it has higher energy, then molecule has to release back its excess energy because it is not participating in the chemical reactor. Then it has to come back to the ground state. Then coming back to the ground state, which happens in two different processes, which are called radiative and non-radiative process. So radiative means we could see the zigzag lines, all the zigzag lines showing that non-radiative transitions. And in that very famous non-radiative process are internal conversion and intersystem crossing. These two processes, through these two processes, molecule loses its energy in the form of heat. Then radiative transition, we can have two more process. One is phosphorescence, that is S1 to S0 transition. Another one is fluorescence, which is T1 to S0 transition. Then this particular diagram explains clearly about all kind of radiative, non-radiative transition, which collectively called photophysical process. So with this, we'll wind up in this today's lecture. So hope you enjoyed my lecture a lot, and I'll catch you in the next video. Thank you.